Hi everyone! This video is about our course project for IIIT where we have worked on personalizing search results. Now one might ask, what is the need for personalization? Well, each person is unique and quite naturally have unique search needs. The web has been moving gradually from a purely textual model to a semantic one, and in order to keep up with the trends, search engines need to understand user intent more clearly and deliver results accordingly. Search and user click history might help the search engine to personalize. Formalizing the goal of our project, given a search query of a particular user and the initial list of results, we aim to re-rank those results depending on what the user had clicked on previously, which can be obtained from his search history. For this project, we have used the Querylog dataset provided by Yandex for the Kaggle Personalized Web Search Challenge. The data represents 1 month of search activity. We train using 27 days of search history, while testing has been done on the remaining 3 days. Privacy is of prime concern when it comes to search logs for users. So, the entire dataset has been anonymized. Everything from search queries to result URLs are assigned unique IDs. This is what our dataset looks like. This added security comes at a cost though. All semantic information is lost. Instead, a purely statistical approach needs to be taken. How much time a user spends on a web page indicates how satisfied she was with that page. We have leveraged this dwell time to learn their preferences. Based on these dwell time, we have judged the relevance of the URLs. Each user can have multiple sessions. In each session, she normally fires more than one query, and for each query, a list of URLs are displayed to her. So we compute our features for each URL query pair. We have employed 3 kinds of features for this task: basic features, user-specific features, and pairwise features. Basic features include query ID, user ID, URL ID, etc. For the user-specific features, we have categorized the URLs into 5 types based on their relevance. The first 3 types corresponds to relevance 0, 1, and 2 respectively. The 4th and 5th types constitute of URLs which were displayed but the user missed them or skipped them respectively. For each URL, we count the frequency of each type and use them as features. The rationale behind using the pairwise features is that if a URL is ranked high up in the search results in an unpersonalized setting, it is very likely that it will be placed high in a personalized setting too. So we take pairs of URLs and their relative rankings as features. Once we have obtained the entire training dataset, we need to use some machine learning techniques and we model this as a regression problem. A key challenge here is the sheer amount of data that we have to deal with. The features generated amounted to 150 GB. This would mean several hours of waiting for the model to train and memory crunch. But thanks to out-of-core learning, we could train our model in just 1 hour. Out-of-core learning algorithms employs hashing trick to ensure all training data is not needed in memory at once. Specifically, we use Warple-Wobbit, which is extremely fast, scalable, and employs learning in a parallel fashion. We evaluate a system using the web interface provided by Kaggle for this challenge. It evaluates the NDCC score of our results. We have built multiple models by taking different combinations of the features described earlier. The best score that we achieved among all the models is 0.7658. The team in this Kaggle competition achieved an NDCC score of 0.80725. We believe some more experimentation with the learning parameters would yield us better results. We hope you enjoyed this video because we thoroughly enjoyed it. Thank you.